Our last topic for chapter 5 is to find the inverse matrix. So we have several steps to take in order to find the inverse of a matrix. So here are 4 steps in total. So the first step, right, for finding the inverse matrix is to find the determinant of the matrix. Right, suppose we want to find out the inverse of A, right, the inverse matrix of A. So the first thing we need to do is to find the determinant of A, right? Because there's a complex equation we didn't use is here, right? So the first step to find the determinant, and the second, we need to find all the cofactors of all the elements of A, and we arrange them as a matrix C. So this matrix C contains all the cofactors of the elements. So here C11 is the cofactor of the element A11, and C12 is the cofactor of A12, right? C1n is the cofactor of A1m. So the corresponding Cn1 or Cn2, the corresponding cofactor is for the corresponding element. So Cn1 is the cofactor of the element An1. Right? So for all the elements of the matrix A, we find all the cofactors for the matrix. So for A11, we have a cofactor called C11, and then for A1n, we have a cofactor of C1n. We find all the cofactors and rearrange them to a matrix C. So this takes a lot of time, right? Because we have to find all the kind of cofactors. And remember, the cofactor is just -1 I plus j, and then the m ij, right? So just C ij. This thing. And the third step, we need to take the transpose of the C, of the matrix we find that above, right here. Take the transpose of C, and we call this matrix adjoint of A. Right, so adjoint of A is defined to be the transpose of C, C prime. And this is just equal to C11, C21, right? Because it's a transpose of C. So here it becomes C21 and then Cn1. So here is C1n and here is Cnn. So adjoint of A is just the transpose of the cofactor matrix C. So that's the third step. And the last step is to divide the adjoint A by the determinant of A that is the first step, right? And the result is just the inverse matrix of A. Right, so it's a little bit complicated to calculate the inverse of A. So we need to find the adjoint of A and then the determinant of A. And then we divide the adjoint A by the determinant of A to find A inverse. Okay, so let's look at example. Right. So find the inverse of this 2 by 2 matrix, which is a very simple one. Okay, so first we need to check if the A inverse exists. Right, so the determinant of A is 3 times, the determinant of A is 3 times 0 minus 1 times 2. Right, so that's minus 2. And it's not 0, so A inverse exists. Okay, so if A inverse exists, and so we can perform the 4 steps above to find that. So first is to find out the determinant of A, which we've already done, right? Because A determinant is just a minus 2. And the second one, so that's the first one. The second step is to find the cofactor matrix. Right, so cofactor matrix C, as I said, this is a 2 by 2 matrix, so it has only 4 elements here. So C11, C12, C21, C22. Okay, so C11, which is the cofactor of A11 here, number 3, right? The number 3. The cofactor of this element means we need to delete the rows and columns where number 3 is at. So we need to delete the first row and the first column. Right? This is where the number 3 lies. And what is left is number 0, just a scalar, 0, right? So we have a 0. And we have to consider the sign before the 0, right? Because 3, the number 3 is A11. And 1 plus 1 is even. So we don't have to add a minus sign before the 0, right? So it's just a 0. And cofactor C12 should be the cofactor of the number 2 here, right? So I first delete the first row and the second column. So we only have one this scalar left. So there's a 1 here. And for the sign, because 2 is A12, and 1 plus 2 is odd. So we need to add a minus sign before the 1 here. Right, so the cofactor of A12 is minus 1. And C21, again, C21 is the cofactor of the element 1. So the cofactor of number 1, the third element, should be deleting the second row and the first column. And we have 2 left, right? So there's a number 2 here. But also the number 1 is A21, and 1 plus 2 is odd again. So we also have a minus sign before the 2. And the last one, C22, which is the cofactor of the 0 element here. So the cofactor of that is to delete, the cofactor of the element 0 is to delete the second row and second column. So I have number 3 left, the 3 right left. And for the 0, it's A22. Now 2 plus 2 is even, right? So there's no minus sign before 3. So the C matrix should be 0, minus 1, minus 2, and 3. Right, so this is step 2. We find out all the cofactors of the elements of A. So step 3, we just need to take the transpose of the matrix C and to find the adjoint of A. Right, so this should be 0, minus 2, minus 1, and 3. Right? And the fourth step, the last step, we calculate the inverse of A by using this equation, the adjoint A divided by the determinant of A. So the adjoint of A is 0, minus 2, minus 1, 3, right? When you divide this matrix by the determinant of A, which is minus 2, so there's a minus 1/2 before that. Right, so minus 1/2 times the matrix means we need to multiply minus 1/2 to all the elements in the matrix, right? So this is 0 and then 1, just a minus 1/2 times minus 2. This 1/2 is minus 1/2 times minus 1. So this is minus 1/2 times 3, right? So we find that the inverse of the A is this matrix. So these are 4 steps we need to do, okay, to find the inverse of A, if it exists. So this is a 2 by 2 matrix, and Here we'll look at a little bit complicated example, which is a 3 by 3 matrix. So we need to find the inverse of B, which is a 3 by 3 matrix. Again, the first thing we need to check if the inverse of B actually exists, right? So the determinant of B, if we expand from the first column here, because there's a 0 here, so it will be easier, right? It should be 4 times the subdeterminant and the plus 3 times the subdeterminant, right? We find that it's 99 and it's not 0, so there is B inverse. We can do that, right? So the first step to find out the B is to find the determinant, which we already done. It's 99. And the second step is to find the cofactor matrix C. So the C matrix should be C11, C12, C13, C21, C22, C23, C31, C32, C33. Right, so we have 9 elements here because we have 9 elements in the matrix B. Right, so the cofactors are 9, and so C11 is a cofactor of B11, and C12 is a cofactor of B12, and so on. Right, so the cofactor of B11, which is the number 4 here, right? We want to find out the cofactor of this element, the first row and first column. Again, we need to delete the first row and the first column where the number 4 lies. And the subdeterminant is 3, 2, 0, and 7. Right, so here is 3, 2, 0, and 7. And because it's B11, so 1 plus 1 is even. So we don't have to add a minus sign before that. So the first cofactor, the B11 cofactor, is just this little determinant here. Right. So for the B12, it's the number 1 here. And to find out the cofactor of this element, we need to delete the first row and second column. What is left is 0, 2, 3, and 7, right? 0, 2, 3, and 7. But because it's one, because it's a B12, so 1 plus 2 is odd. We need to add a minus sign before this subdeterminant. So the cofactor for B12 is minus and times the subdeterminant here. Right. And we can do that one by one for all the 9 elements, and then write down the C matrix here. So this huge matrix is the cofactor matrix that we need to calculate. Okay, so for all the 9 elements, each of them will have a cofactor with or without a negative sign here. So we need to find the 9 of them, and then we need to calculate the determinant of the 9 elements and find out the answer. Right, so for example, the first one is equal to 21 minus 0. Right, so it's 21. So the second one, it should be minus 0 minus 6. Right, so it's 6. So the third one, the determinant is 0 minus 9. Right, so it's minus 9. So we calculate the determinant of all the 9 elements, all the 2 by 2 determinants here. And we find out the matrix C is this. Right, it takes a lot of time calculating these things. But finally, we'll find the determinant. So finally, we'll find the cofactor matrix instead, like this. So that's the second step. And the third step is to find the adjoint of B, which is just the transpose of C. So we take the transpose of the previous matrix and find out it's this one. And step 4, the B inverse, which is our last step, right? The B inverse is the adjoint B divided by the determinant of B. So it's this matrix, the same matrix as before, and divided by the determinant of B is 99, right? So there's a 1 over 99 in front of the adjoint of B. So this matrix is the B inverse we want to find. So in summary, there are 4 steps you need to do to find the inverse of a matrix. And the most important one and most complicated one is to find the cofactor matrix C. Right? It takes a lot of time in finding that. But after you find the matrix C, and the rest of them will be very easy to do.